No one's here yet. It's just me. All right, there we go. Okay. I have no weeks displayed for you. It's because there's no homework this first week. I know that's really disappointing to hear. Uh, Nothing. Using the content library. New section called slides. And I will delete that. And what did I just do? It's just no, I want this review. Okay, yeah, there we go. I guess I should pull up the syllabus too, because we got a brand new one of those. It now says spring instead of fall, and the structure has changed ever so slightly. All right, there. And, well, I don't know where everyone went. Where did everyone go? Oh, welcome back, everyone. They show the Brady Bunch video at Chapel. Okay, I missed it. They did tell me they used my joke one though, where I look shocked to see President Lewis next to me. We did a few takes of it. Be like, all right, can you really look surprised when you see him? Just sort of like, I thought they were gonna go with the boring one. Just me smiling back. Oh well. Hi, welcome back. And you must be Keelan? Okay. There you go. A syllabus. All right. I got Abigail here online. Well, let me see who all is here. I got to do attendance on the first day at least. But thankfully, I now know everybody, so this will go fast. Here you go, Vita. All right, so Connor is here. Jerry is here. Lee is here. Megan's here. Vita's here. Zachary's here. No Keaton. He's the most excited about calculus. He sits right here. You can't get any closer, right? Wow, where is he? All right, Keelan is here though. Elizabeth, Sydney, you've got to be here eventually. She'll be here, but Abby's here. All right, Joshua Swanson is here. Maxwell's here. Yeah, Yehan. All right. Oh, I forgot your anglicized name. What? It's April. That's thank you. All right, there we go, April. Okay. Well, welcome back to calculus, everyone. I know you couldn't wait for this. 12 o'clock time to get started. It's a new section, so we get a new syllabus. Not too much has changed though. My office is still right there behind that blackboard. So feel free to drop by whenever. I have the same materials. My office hours are a little different though. Um, just so you know, for a few of you who are new to the course, um, I basically, if my door is open to my office, you can come in and ask a math question. That's fine. And I have official office hours because the college requires it, but I'm available almost all day, like Tuesday, Thursday, pretty much all day because I don't teach on those days anymore, or at least not this semester. Good, Keaton is here. I knew it. Getting worried. I was like, somebody, we got to send out a reconnaissance squad. I don't know what happened to him. Oh, we're doing web work. Yeah, it is. It's there. Yeah, no, the web work's still there. I actually printed this in color, so the tentative calendar looks really nice. Um, so yeah, basically we're going to continue learning calculus, everyone. That's what we're going to do. We've got some course outcomes. We've got kind of roughly the same breakdown for assignments. There's still web work. I've set up the server. Um, no wiss-ups. No wiss-ups. There's a project instead. The wiss-ups are secretly, so what happens in my life happens in a lot. What happens is we give a project, and if I've never had to give you a hard time for writing before you submit a project, like a written report, it's a disaster. It's a literal disaster for everyone, for me, for you, everybody. And so the wiss-ups are my way of saying, okay, I'm going to make sure that we're on the same page with what writing math looks like. And now I can give you a project to work on and you can write up a report. In theory, in theory. So, so no wiss-ups, but there is a bigger project. I'll go into that project later in the semester. Same structure with exams. We've got 3 exams and a final exam. We still have exam corrections as a possibility for exams. I forgot I included this. All right. We had one provost who was like, you should include references to all the criteria in academic college, in academic catalogs. So I, a little bit tongue in cheek here, was like, a veritable treasure of organizational policy and procedures awaits you, the student, in the college's course catalog. Okay. I forgot that was in there. So if you want to read academic policy, have at it. Uh, just as before, self-reporting of disabilities. So if you've had a learning accommodation in the past, please feel free to pursue that for this course. Academic integrity hasn't changed. We have math tea time. We have math tea time, everyone. And math tea time is Mondays at 4 p.m. It's just a time for the math department to get together, drink tea, have a dessert, and chat. And usually a math problem is there to entertain us as well, because it's math. But feel free to show up. You can freeload on our desserts. I think today is Rebecca. She gets to do that. So feel free to show up to that. Calculus at night is still a thing. We no longer have our beloved in-class TA, Andrew. So Andrew will not be here to help you learn calculus in the classroom, but he will be available at calculus at night. So if you're like, I need some more Andrew Bow time, good news, he's still around. Okay, so I think I forgot the exact time on it, but it's not going to be this week, so it doesn't matter. It'll be on Tuesdays. All right. Um, the tentative calendar, just so we're clear, on Monday of next week, we have no class due to MLK Day festivities. So don't show up. Nothing happening. We are okay. And you can see that there's a lot of unusual breaks and things during the spring semester. I mean, there's like this winter break, which is nice, but then we have like advising day on like March 13th, no class. And then Easter break, and that's it. That's it for breaks. So you can take a look at the topics we're going to be covering this semester. There's quite a bit of them. Roughly speaking, most of this material is just using the differentiation rules we learned last semester to solve various types of problems. So all the way up until break, we're just using derivatives. And then in the second half of the semester, we're going to start learning about something called integrals. And integrals are something, they're kind of like the opposite of derivatives. Well, I'll go into what those are later. But once you learn derivatives and integrals, you are well prepared for any calculus or physics you encounter later. So I'm not going to pretend. Oh, by the way, just as before, I'm using OneNote again. You all have your own individual folders, but these are really just meant for the online students, but I give them to you anyways. Keelan, you may not know this, but I use OneNote. Have you ever heard of it before? I can tell you more about it later. It's basically just, it's a Microsoft product. You have free access to it on office.com. And what it does is it allows me to write notes on a screen that you can then look back on. Also, as before, every class period will be recorded and posted on a YouTube playlist, so that if you want to remember what we did, you can actually go back and watch it. Well, if you want to have concrete evidence to show that your teacher occasionally gets off topic, yeah, the internet is forever, right? That's what they say. All right. Now, where did I put that? I thought I had, did I just confuse my, oh, there it is. Yeah, there it is. So today we're going to just review everything because I think maybe over all the festivities of the holidays, you might have forgotten some calculus. It's a possibility. It's a possibility. And so we're just going to spend class reviewing. So differentiation review. I want to remind you of the big rules we have for taking derivatives. They are the product rule, quotient rule, and chain rule. And that's it. Those are the rules. And oh, and the general power rule. And so since it's been a while, I'll work through a few examples here just to illustrate it. The only thing is I'm looking to see in my notes if I actually have any pre-made examples I intended to go through. I'm guessing the answer to that is no, because I can usually, oh, no. I got answers. It's not examples. Oh, it's okay. We can make up examples. All right, let me just take a look at the certified. All right, so let's do some examples here. Well, we'll call this one example one here. Example one. Let's suppose we had let's call this function p of x. Our p of x was like this thing: x to the fourth minus 3x squared plus 2 times x to the fifth minus 1/2 x cubed plus x. Ugh. All right, let's suppose you're asked to take the derivative of that. Well, you've got two options. One is you multiply it all out and then take the derivative. That's going to be extremely painful. You will get 9 separate terms if you multiply it all out. I highly recommend not doing that. And what's the other option? Product rule. That good old American product rule. Okay, it's not really American. It's probably German or French. All right, that's all right. So to use the product rule, I need to remember how on earth I take a derivative. Does anyone remember what's the derivative of x to the fourth? I'm counting on you remembering nothing. 4x cubed. Oh, yeah. All right. Yeah. Keaton remembers. How about negative 3x squared? Okay. Oh, Elizabeth has got, and derivative of 2 is 0. Okay. All right. All right. This front row, is 3 for 3. Good job. All right. G prime of X. All right. I think 5x to the fourth. All right. Net. Ooh, hard one. What's this one? 3/2. Yeah. -3/2 with a x to the what? Yeah, sure. X squared. All right. There we go. So you take those two derivatives and you recall the product rule. And so it really just involves writing down what P prime of X is. Just do f of X times G prime of X. So my f of X is this x to the fourth minus 3x squared plus 2. My G prime of X is 5x to the fourth minus 3/2 x squared plus 1. And then here, I'm going to stick the plus down there because I won't be able to keep track of it all. All right, and then the G, well, the f prime is 4x cubed minus 6x. And the G is x to the fifth minus 1/2 x cubed plus x. And as usual, as is my custom, it's time to highlight. Yeah, yellow for f of x right there. Blue for g of x. I forgot the x. Oh yeah, you're right. It's just, well, I got half of it. All right, there we go. Blue right there, and then the derivatives. Let's that there, and I'm done. I'm done with coloring. So there you can see it. It all works out. All right, that's the product rule, everyone. Okay, let's move on to something more exciting like the quotient rule. Do an example of that, just refresh our memories. I trust that Sydney who came into this. Yeah, yeah, there you are. There you are. Okay. Welcome back to class,
Sorry,
Sydney.
like the Wi-Fi in the school just stopped working.
The
And I
Wi-Fi in the
just,
school just stopped. Yeah, yeah, that happens.
did I miss anything?
No, not real. I just went over the syllabus and asked everyone how they were doing and stuff like that. Nothing fancy.
Okay.
Basically, very little has changed. There's no longer WIS-ups. There's now a project instead. So there we go. Okay. All right. Haha. Let's try doing this one. All right. What rule should we use for this? Quotient rule. Okay, very good. Yep, you remember. All right. Now, square root of x, that's inconvenient to work with. What do we normally write that as? X to the 1/2. Yep. And then the g of x, which is the denominator, that's going to stay the same. That'll be x cubed just as it is. All right, let's do some derivatives. F prime of x. What's that going to be? Negative 1/2, right? Yeah, right. Because when you take the derivative when it's just an x there, it's 1/2 minus 1. And 1/2 minus 1 is negative 1/2. And what's the derivative of -3? 0, yeah. All right, and then 3x squared. All right, and what's this next one going to be? Positive 1/2 x to the, no, -3/2. Yeah. If you subtract 1 from -1/2, yeah. Lee's on a roll today. He's remembering all of calculus. This is very good. And now we just use the good old product rule. Okay, so the product rule, sometimes it's worth just, looking back and seeing it, but it's low times derivative of high. So G is low, F is high. Low D high minus high D low. That's a common mnemonic for remembering this. And so I'll have this x cubed. Notice how I love putting this in parentheses because it's wrong if I don't. All right, low D high. Okay, 1/2 x to the negative 1/2 minus high. All right, so the high, I'm going to write it with the x to the 1/2. That's fine. Times that. And although it's really fun to think about simplifying this as much as we can, we do not. We let it be messy. That negative's just a little off there. Okay. I think I did that right. Here, let's bust out the highlighters. F of x right there. F of x there. G of x here, G of x there, G of x there, G of x there, and pink. I don't know, maybe you guys like this highlighting thing. I was doing some of my own math work. So one of the great things about being a professor,
Oh, wait,
yeah,
I'm
did I highlight the
confused.
wrong thing?
I
Oh, I
feel like
sure
it
did.
did.
Oh, I
Because I thought
definitely
the
did.
G of X is first. Never mind.
Uh-oh, uh-oh. No, you're right. I colored all wrong, all wrong. I did that on purpose so you would learn. Right, okay, all right. I was doing this really hard mathematical argument the other day, and I was come on, just erase, just I'm trying to erase just the dang, OneNote, I don't know why we have this kind of sometimes OneNote feels like it's the app for me. Like there's just one app in the world for me, but sometimes OneNote can be so mean. I just don't know if we're meant to be together sometimes. I just don't. Truth is, I've been seeing other drawing apps. I have been trying out Journal Plus Plus. It's pretty good. It's pretty good. I'll say this about Journal Plus Plus Plus. It doesn't complain nearly as much as OneNote. Okay. Seems happy with who I am as a person. All right. I'm not giving relationship advice. I'm talking about drawing apps, but I was trying to do this math here. It's really complicated. I found that highlighting helped me make sense of it because it was getting a little too crazy. All right. Okay. Okay. Continuing on. Example 3. Yeah, let's do a crazy one. Not that crazy, short one. And then I'll just throw you at a bunch of derivatives and see what happens. All right, example 3. I don't know. We'll call this R of x. X cubed plus 2x minus 1 to the 2024. My goodness. All right, we got 2 options for this one. What rule do you want to use? Yeah, you can use a chain rule or you can use a general power rule. The general power rule is really nice because it's like the chain rule, but specialized. Specialized to when you just have a function to the nth power. So I just took a little picture of that there, and I'm gonna remind myself of it right here. And so in this problem, oh man, I'll put it up there. In this problem, my g of x is going to be what? That's right, x cubed plus 2x minus 1. And what's my n? 2024. My goodness. I can't believe. I know, you gotta understand, when I was a kid, we were convinced we'd be driving flying cars by now. We really did. We were like, flying cars, it's gonna happen. It didn't. Back to the Future was wrong. Very disappointed. All right. That was one of my favorite movie franchises as a kid. Just, it was, I mean, the hoverboard came close, right? I don't, all right. Okay, and so using this rule, I'll get 24 here, and then I'll have x cubed plus 2x minus 1 to the, and then I subtract 1, 2023 times g prime 3x squared plus 2. There we go. So many derivatives. Ah, any questions on this? You ready to just do a bunch of derivatives on your own? You're chomping at the bit, ready to go. I won't stop you. Here you go. Derivative palooza. I'm just gonna freeze the screen real quick, and then I'm gonna copy the differentiation rules next to it so you have easy reference. Just go for it, kids. I don't know if you could tell, but there was a time when I was tuning out in chapel. Just kind of not really paying as much attention as I should. Next thing I know, President Lewis mentions me. I'm like, dang. I don't know if he saw I wasn't paying attention as well as I should, but I think he might have. Might have. That's okay. Me and Katrina, we can we can be the bad students in the classroom together. Online students. Katrina, Dr. K. I'm sorry, Dr. K. She's one of our physics professors. All right. It's good for you to memorize all these rules, by the way. Definitely memorize them. All right, look, I magically put all the rules there for you. Oh, you're using paper. I'm really, oh, it's my syllabus. Okay. Okay. All right. All right. Oh, hey, yeah. I didn't know you did it digitally now.
Yeah, I got
You
one, so I thought we
might as well, yeah.
buy paper at this point.
How's it going? I know it's been a while since you've had this sort of stuff.
I think I at least got the first one. Yeah, most of them.
Okay. Yeah, yeah. Feel free to ask the folks around you if you ever really get stuck. Looks like Connor's off to a good start there. How's it going, online students? I'm guessing it's going okay if you're saying nothing. That's fine with me. Whoa. Does this look familiar? Yeah, right. This is where we pick up. Okay. Hang in there. Going okay? Okay. Yeah. Memorize the rules. I don't know how. Well, I stuck all those crazy letters there, huh? You might say to yourself, why does he make functions that aren't just functions of x? Why does he throw in a t there or a s or a theta? It's going to be necessary. That's why. Elin, have you seen web work? Okay, good. You don't have to do the tutorial then. You're good. Oh boy. Everyone's very quiet. That's fine as long as you're doing math. That's correct, at least for part A. And it shouldn't be -3/2 for both of these. One of them should be different. How's it going, Josh? Okay, okay. I think the answer for part B is a little off.
Okay.
So the x, that's correct. The x to the -1/2 one is, but that should not be x to the 1/2.
Okay.
How's it going, April? Okay. Well, all's quiet here online, students. They're just busy plugging away. Do you have any questions for me? Anything you want to check?
Are we supposed to simplify for problem C or just leave it how it is?
Nah, just leave it as it is.
Okay.
Simplifying is fun, of course, but it's also a pathway to which you can turn a correct answer into an incorrect one. So I want you to get the problems right. We're going to practice simplifying those later once we get to topics like optimization. But for now, not going to worry about it. Yeah, which problem are you doing? Well, yeah, it depends what, so like for D, there's a T variable there, so you treat T like X. But yeah, this is correct. That's correct. Yeah, correct. I'm gonna write down some answers so you can check your work, at least for the first few, not for all.
Wait, for C, why is it in the denominator just x squared? Shouldn't it be
Oh,
like,
yeah, you're right. You're right.
sorry.
There, no. Oh, that looks better. Yeah. Yeah, it's better to have the right answer than the wrong one. Agree. How goes the back of the syllabus? Yeah, pretty good, man. Yeah. Yeah, me too. I think we're both doing it correct. Did I write something wrong? Oh yeah, it's a 6x squared. Good. No, I really know how to teach. I really know calculus. For real. For real. Yeah. How's it going?
For this one, wouldn't that be 1/2? Because we subtract one.
Yeah, if you subtract one from negative 1/2. Yeah. Yeah, very common thing to do. How's it going, Connor and Maxwell? Okay. Isn't it just, I don't know. Is it relaxing to just sit and do a bunch of derivatives? You're like, I'm back to my first class and I'm just, it kind of like depends on if you're that like kid and I don't know if they still do this. When I was in like third grade, they'd give you like a problem, they'd give you a sheet with like 60 addition problems or subtraction problems and just say, go for it, kiddos. Yeah. Yeah, I think they called them mad minutes or something. Like you're supposed to do it in a minute. Yeah, did anyone else do those? Yeah. I was never the fastest. I was the third fastest. Third fastest. Oh, you were the fastest? Oh, good job. Good job. Yeah, they crushed the competition. They never. No, no, Kristen and Marissa were always just a hair faster than me. A hair. They beat me. The other thing is they would do it right. Eh, I did it mostly right. Most of them right. What I really liked when I was a kid, first grade, was spelling. And our teacher let us pick our own spelling word for our spelling test. And I picked the word Tyrannosaurus Rex. And I got my spelling test and I spelled Tyrannosaurus Rex correctly. But I did not get 100 on the spelling test because I misspelled Brandon. I misspelled my name. Like I was really focused on that dinosaur. Like, put it nailed it. Oh well. How's it going? That's the good old quotient rule. You can do it that way. There's a couple different ways to do it. But the quotient rule is really handy for that one.
Oh,
Did you do them all?
Isn't regular just?
It's a quotient rule followed by another rule. Yeah, it's one of those. All right. I'm willing to take requests. Is there any derivative here you'd like to see a solution to? Shall we do I together? I is mean. Look at that thing. Yeah, let's do that. All right, so here it is. G of t is that. All right, what rule do you think we should use? One step at a time. We're not going to bite off more than we can chew. Yes, we're going to use the quotient rule. So I'm going to use the quotient rule with u and v because this one is called g. So let me just remind you of the quotient rule with u and v. There we go. All right, that's it. So my u is going to be 3t squared. My v is going to be this thingy. Now, there is an exceptionally sneaky way of doing this problem, but I'm not going to show you the sneaky way. Maybe one of you can see the sneaky way. I'll show it to you after. Oh, no, wait. I forgot the minus. All right, there is no sneaky way. If it were a +1, you could do it a sneaky way, but -1, no. Yeah, you could factor it, and it'd be t + 1 squared, and you could cancel the, yeah, but no, not this time. All right, u prime. Looks like I avoided that. I'll have a 6t there. And for v prime, what rule? Yeah, the general power rule to the rescue again. And so I'll move the 1/2 down. Yeah, it's the same thing in a sense. I subtract 1 from the exponent. And then when it's the general power rule, the only thing I have to remember to do is multiply by the derivative of the part in parentheses. So I should get 2t + 2. And then g prime of t, I just literally plug all this in. So just to recap, there's my quotient rule vu prime. So my v is t squared plus 2t minus 1 to the 1/2 times the u prime, which is 6t minus a 3t squared times my v times the v prime. Look at that thing. Okay, I can see why you asked me to do this. It's awful. All right, there we go. Look at that. All right. And then I need the v squared. So the v squared is going to be this thing squared. And do you see what happens? What happens when you square a square root? They cancel each other in an ideal world. There we go. That's it. That's it. That's the problem. All right. So that's the quotient rule, product rule, chain rule, general power rule, and all its glory. Now I just need to remind you of a few more derivatives so we can practice some more problems. And then maybe next class, I'll introduce new things, but I want to make sure you remember this stuff. Okay, first thing to remember is the idea of what we called higher order derivatives. So we had this idea of an nth derivative, for instance, a second derivative, third derivative, fourth derivative, and so forth. And then we also had derivatives of trig functions. And so the two most important are sine and cosine. The derivative of sine is cosine, and the derivative of cosine is negative sine. And then the other ones can be derived from these two, but it's good to memorize the formulas nonetheless. The derivative of tangent is secant squared. Derivative of secant is really weird. It's secant times tangent. Derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. Very strange derivatives. You should 100% at least memorize these first three derivatives of sine, cosine, and tangent. Start with those. Those are the most important ones to like keep in your memory. But with that in mind, let's do a few problems. I'm sorry, I moved away before you wrote them down. It'll be back. We'll be back. But let's do an example. I had example 4 and 5 there on the slides, but I'm just going to do example 4. It'll be a 4 and 5 mashup together. All right, so imagine I had this function here, sine of 3x. Here, let me just make sure I didn't make that as a problem down here. Sine of 3x down there? No. All right, we're good. All right. I've done that before. Sometimes I'll make up a random problem and it just happens to be the random problem I have for you to do. All right. Now, suppose I want to figure out what my f prime of x is. How would I do that? What's that derivative going to be? Yeah. Oh, yeah, essentially. What I need to do is I need to use the chain rule for this one. So the chain rule, just to recap, says that if you have two functions composed together, an f with a g on the inside, it's f prime of g of x times g prime of x. You could have done some of the problems before using the chain rule, but it didn't really come up naturally. And so, man, I'm already using, let's call this thing p of x there. Now it's not called f of x. And so in this problem here, what's my inside function? What's my g of x? And what's my outside function? Yeah, 3x and sine of x. And so now if I want to take the derivative, I need to figure out what my f prime of x is. So what's the derivative of sine? Cosine. And the derivative of 3x is just 3. And so this will just be cosine 3x times 3, or if you prefer, 3 cosine of 3x. So that's the derivative, first derivative there. Now imagine for some bizarre reason, I wanted the second derivative. Or how would I take the second derivative of this? Do it again, yeah. Again. I need to identify an inside function and an outside. All right, the inside is still 3x. What's the outside going to be? 3 cosine x, yeah. And what's the derivative of that going to be? Derivative, what's the derivative of cosine again? Negative sine, yeah. Negative 3 sine x, and the derivative of 3x is just, well, 3. All right. And so now I can figure out the second derivative. All right, so that is going to, again, just to reiterate, it's going to be my f prime g of x, g prime of x. And now I just need to plug in what those things are. So I will have, sometimes I like to do this in stages. So first I take my f prime, and wherever I see an x, I just write g of x, just to make it easier for me to think through. And so I'll leave a g of x there and a g prime of x there. So all I did there was plug the g of x symbol into f prime. So wherever there was an x there, I stuck g of x. And then after I do that, I find it very convenient to then just plug in what g of x is. And g prime of x is, and so I get -9 sine 3x. All right. And that right there is a second derivative. And you could take third derivatives, fourth derivatives. Believe it or not, in Calc 2, we have a process where we take all the derivatives. Like, let's find the third, fourth, fifth, keep going, the nth derivative. But one step at a time, one step at a time. All right, so I have a bunch of problems for you here. Man, look at all those. I'll put up the trig derivative facts nearby in just a second. I just got to freeze the screen while I do it because it's kind of messy. Yeah, try those out. Take some derivatives. I'll, I know I just pasted that somewhere. Where did I paste it? There we go. Oh, I shouldn't do it that way. I should just do it the other way. You know, it must be exciting. You go to all these other courses and it's kind of brand new and new professors, and then you got me again. Sorry. That's just the way life is. At least it's predictable. There you go. All right. Ooh, just derivatives nonstop, huh? Oh no, my laptop came up here. You know, these USB-C chargers really are not the best for laptops. Oh, part B is mean, huh? Look at that thing. I'll do the best you can. This isn't quite right. It is true that it'll be a 4, but you need to use
Yeah,
the
I need to-
general power rule on that one. Yeah, I know. I like started with like, okay, this is similar to what I just did in an example. And then in part B, I just went crazy. Yep. Yeah. Apparently I got very ambitious here in number two. I was like, let's push the limit here with part B. We'll make it crazy. Hopefully you enjoy that sort of thing. It's a lot to remember, I know.
I think the temperature. Oh, good. Should we plus from the east?
Yeah. What you want to do is just sort of set up a nice little chain rule problem, identify the outside function and the inside function, and just kind of go. So yeah, your outside function is going to be 3 cosine. And so the derivative of that will be -3 sine. Yeah, I should probably actually go over that one. that one might be a little mean. That might be. I could see I got something in the chat here. Why is there a y in part D? There's a good reason for that. It's because the next topic I'm going to discuss is called implicit differentiation, and I need you to be slightly familiar with it. That's why there's a y. Okay. Shall I go over part B, everyone? Such a mean problem. What was I thinking? Kind of like, I don't know. Kind of reminds me of my high school days. Sometimes you just wanted to do something extreme because it was extreme. Used to have this, you'd play football outside. We called it Wimbledon because it'd be like below 0, freezing cold. And the goal of the game wasn't to win the football, it was to be the last one to go inside. That was the goal. That's kind of what motivated this problem. Kind of like an endurance. Okay. What's a derivative of 1? It's 0, right? All right. Now for the derivative of a cosine, I could write out the chain rule at this point, but we're getting to a point where we might be able to just do it in our head, and that's okay. So in this chain rule, I recognize that I have an inside term there of 2x and an outside term of negative cosine. What's the derivative of negative cosine? Positive sine, yeah. So the outside function is the derivative of the outside function is sine. The 2x stays in there, and then I have to multiply by the derivative of the inside function. And what's that going to be? 2, yeah. And then after doing that, I have to take the derivative of this thingy. Now, that means I'm taking the derivative of really, so there's that cosine squared there, but in the back of my mind, I'm really thinking this is cosine of x squared. And what rule should I use for this? I actually have 2 options, one of which is slightly easier. Yeah, the general power rule works again. And rather than writing it all out in detail, because you can tell I'm growing weary of that. My g of x in the general power rule, that's going to be, so I'm going to move the exponent down. I'll get a cosine of x, and then what must I do? Yeah, negative sine of x is right. So let me write that down in detail, even though I said I wouldn't. So the derivative of g of x to the n, just in general, if you have something to a power, and g of x to the n minus 1. In this case, Oh, times g prime of x. Right there. This is fulfilling the role of n g of x to the n minus 1. And this is fulfilling the role of g prime of x. And that would be a fine final answer, though I think it looks a little weird. And so I'm going to write this as 2 sine 2x. And then I'll have a 2 times a negative. So that'll be a -4 cosine x sine x. And if you know some fancy trigonometry, which I don't expect you to know, but cosine x times sine x actually simplifies pretty nicely. But I'm just going to leave it as is, okay? You don't have to use trig identities there. So that's how to do part B. I think. Let me double check with my answer. This is, you may be thinking to yourself, Brandon, where do you get your answers for group work problems? Well, I get them from myself. So it's really like I'm consulting with past Brandon. What did past Brandon think? And past Brandon says this is correct. Way to go, past Brandon. Can we do D? I'm confused. Would you like to do part D as well? In-person students, yeah? Oh, goodness. Why did I assign that one? Okay, all right. How are we doing on time though? I may just wait to do that one. Here, I want you to work for like 4 minutes and then I'm going to do part D, okay? But try out a few more of these. Well, we'll finish up by doing part D. I know, it's like you were at home opening your Christmas presents, playing on your Xbox or whatever it is. And now you've had like an hour of derivatives straight. Moments like this that cause you to question your priority. How goes it?
Goes.
It goes. All right. Ooh. Part C is mean because it's a second derivative. Maybe I'll do part C here real quick. We'll just write it here so we can see everything at once. Yeah, let's do part C together. Well, what rule should we use to take the first derivative? What was that? Chain rule, yeah. And so my outside function is going to be this 1/2 cosecant. Inside is going to be 2x. All right, what's the derivative of 1/2 cosecant? Oh dear, look at that. It's complicated, isn't it? Very complicated. All right, yeah, I'll have a negative 1/2 out in front, and then I'll have cosecant of well something. Oh, because there's a negative here in the derivative, and there's a 1/2 there. So I'll have cosecant of stuff, cotangent of stuff. What's the stuff that goes in the parentheses here? Yeah, 2x, right? You take the derivative of the outside, keep the inside the same, and then what's the last step? Yeah, just multiply by 2. And okay, and now it simplifies kind of nicely. Now it's just cosecant 2x cotangent 2x. So to do this problem, we had to use the chain rule. To do the rest of it though, oh my goodness. What rule do you think we should use here? It won't be quite that. Product. Yeah, we're gonna start with the product rule on this one. And actually, it might be worth just writing down what things are when it gets complicated like this. So this will be my U, and this will be my V. I need to figure out what my U prime and my V prime are. So for my U prime, this is a little mean. All right, my original function was 1/2 cosecant 2x. I now just want to take the derivative of negative cosecant 2x. It's very similar. So I'm in some sense repeating the problem I just did. I'm going to identify my outside function. My outside, I screwed something up there. My outside function is cosecant, and the derivative of that outside function is negative cosecant cotangent. But because there's a negative there, the negatives cancel out. And so I'm going to get cosecant of stuff times cotangent. There's an O there. Cotangent of stuff. Yeah, well, so what happens is I have the negative here when I take the derivative of the cosecant, but then the negative there cancels it out. Yeah, the negatives just, when you multiply two negatives, they cancel. All right, and what goes on the inside is still 2x, and what do I multiply by at the end? 2, yeah. And then I'm going to do the same thing for v prime. And v prime, all right, now I got to take the derivative of cotangent. But I got to use the chain rule, right? So my outside function is cotangent. So the derivative of cotangent is negative cosecant squared. And so I'll have negative cosecant squared. And what goes on the inside? This is 2x, yeah. And then I got to multiply by 2, yeah. You can tell this is, it's pretty complicated pretty quick, huh? Like you're just like, oh my goodness. Basically what's happening now is I'm beginning to not write down every step in detail. And unfortunately, that's a skill you'll have to develop as well. Eventually, you're just taking derivatives in your head, following the rules. In Calc 2, this is especially critical. All right, and so now I can write down what y double prime is. The product rule tells me it'll be u times v prime. So I'll have a negative cosecant 2x, that's my u right there, times my v prime negative cosecant squared 2x times 2. Now I'm going to write down what these are. This is u, this is v prime, plus, and then it's going to be u prime v. So u prime is, that thing, cosecant 2x cotangent 2x times 2. That's my u prime, and then I'm going to multiply it by v, which is cotangent 2x. And I could just leave it like that if I'm traumatized enough. But then like, look, I had too much. Sydney, I don't think I'm going to get to part D. I will next class though. But if you're not traumatized enough, you can simplify it some more. All right. There we go. Whew. Complicated, huh? Yeah, well, we'll practice some on Wednesday. Some more, and then you'll have practice on your homework and you'll just get lots of practice. All right. Online students, any questions before I hang up? All right, you can see my face. Sorry, I didn't get to it, Sydney. I'll get to part D eventually. I will. We'll do it. Okay. All right. Well, I don't hear any questions, so I'm gonna hang up. I'll see you guys later. Bye. Hey, is that a map of Israel? Yes. You know, I lived there for a year. I did. Yeah,
I'm in
yeah, I lived in
principal's
Tel Aviv.
office.
What's that?
I'm in my principal's office right now.
Oh, okay. Oh, that's not your map. Okay, all right. Yeah, I used to live in Tel Aviv. It was fun. All right. Except for when Hamas launched missiles at me. Then it wasn't as much fun. Had to run and hide, but I made it. All right. I'll see you later. Bye.